a wire of length 2 meter, that is L equals to meter, and cross-sectional area A equals to 1 into 10 to the power minus 6 meter square, that is 10 to the power minus 6 meter square. Okay, is stretched by a force of 200 Newton, that is applied force is 200 Newton. If the Young's modulus of the material is Y equals to into 10 to the power 11 Newton per meter square. Find the elongation in the wire. Okay, let's have a wire. Consider this is an wire and the length of the wire is L. And we are applying some force F here. For this reason, there is an elongation delta L. And this is our cross-sectional area A. Now, the formula says us F by A equals to Y into delta L by L. So from this we can easily calculate the delta L, or delta L equals to F L by A into Y, or delta L equals to F is 200 and L is, and A 10 to the power minus 6, Y is 2 into 10 to the power 11. So, and there comes 200 by 10 to the power, there is minus 6 and 11, so 10 to the power 5, and 200 into 10 to the power minus 5, the unit will be meter, and 2 into 10 to the power minus 3 meter, that is 2 millimeter, and this is our answer.